Hi, everyone. I am Shakib Mehri. I lead some of our research efforts at Contextual AI. Today, I want to talk about why one size doesn't fit all in enterprise AI and how to build agents that actually work for your business. I've been thinking about this problem for a long time. I started my PhD right about when BERT and GPT-1 were first published and finished right before ChatGPT came out. So basically, I've spent the last 7 years thinking about how we can leverage these increasingly powerful foundation models while still benefiting from human expertise and task-specific inductive biases. So let's dive in. How do you make AI work for your enterprise needs? But first, let me explain briefly what contextual AI does. Our core goal is to unlock AI's potential for every employee by combining your enterprise data with foundational models and your institutional knowledge. The challenge is that this combination is not only unique to each industry and each company, but likely for each user within each team. Every employee has their own workflows, internal knowledge, habits, and preferences that need to be reflected and accommodated if an AI tool is meant to be impactful. At Contextual AI, we built an end-to-end platform that makes specialized AI possible. It has three core parts: data understanding that ingests your messy enterprise data, a RAG agent that dynamically retrieves and reasons with state-of-the-art accuracy, and a specialization engine that tunes everything for your specific needs. And we serve three different audiences. Business users get no-code solutions, developers get access to our full APIs, and ML engineers can access our raw components. And each of our components, including our re-ranker, our grounded language model, our evaluation model LMUNit, is built to serve the needs of enterprises and achieve state-of-the-art results on the relevant public benchmarks. Now let's talk about the research that makes all of this possible. Here's the reality. Generic foundational models consistently struggle with real enterprise tasks. They hallucinate critical information, they ignore your carefully crafted business rules, and they simply don't understand your domain. The core issue is that they're built to be generic, jacks of all trades. But your business is not generic. It's specialized with unique requirements, terminology, constraints, and tribal knowledge. At Contextual AI, we built the components and the specialization recipes that enable our agents to consistently outperform these generic foundational models on things that actually matter to enterprises. And I'll walk you through in this talk the 5 key pieces that transform generic AI into specialized AI, specifically context, grounding, evaluation, dynamic agents, and our specialization recipe. And each one of these builds on the previous, and combined they create AI that's truly yours. So let's start with context, because models can't answer questions about information that they don't know about. The fundamental challenge is that parametric knowledge, what's baked into the model's weights, simply is not enough for enterprise use cases. Your internal documentation, the most recent updates to your knowledge, your domain-specific data, none of that exists in the model's training data. A model that is off the shelf is not going to know any of these things. So that means that retrieval is definitely necessary. But here's where it gets tricky. Enterprise knowledge doesn't just live in nice, clean text files that you can upload and have models reason about. There's a lot of complexity here. There's multimodal PDFs with embedded tables and figures that need sophisticated parsing just to extract usable text that can be put into the context window of a model. Or there's structured databases with hundreds of tables and cryptic column names that would confuse any human, let alone a model. And then finally, you need complementary retrieval paradigms, unstructured search for document and text, and NL to SQL for structured data. And you need to leverage both of these together to effectively retrieve across all enterprise data sources and ensure that your models have the right context. So in terms of context, this is a quick overview of 3 state-of-the-art components that Contextual has built and shipped to our users that enable retrieving the right context. First, our multimodal document parser. It's able to understand complex enterprise PDFs with embedded tables, figures, and hierarchical structures. And we go beyond just text extraction. We also preserve the relationships across the documents that matter. Second, our instruction following re-ranker. This is very unique because it actually listens to your instructions, the same way that people are able to derive so much value from prompting language models. We have brought that ability to re-rankers as well. You can tell it to prioritize recent documents or prefer technical specifications over blog posts, and it does exactly that. It's also state of the art on the beer benchmark, which is a popular benchmark for retrieval. And then third, our text to SQL system, which was state of the art on the BERT benchmark, but I think it's dropped a few spots in the past 2 months. But basically, what this does is it considers the entire schema of your database, it considers your natural language query, and it generates exactly the right query to get the information that is needed from your complex database, handling those cryptic column names and complex schemas that are the reality in all enterprise data. These three components work together to extract precisely the right context from your messy real-world data sources. I'm not going to go into more depth about these components, but we have blog posts about all of these that go into pretty good technical depth about them. What I will talk a bit more about is our grounded language model. So let me set the stage here. When you're building agents for enterprise use, what do you actually need from a language model? Honestly, you don't really care if your model knows obscure historical facts or can write poetry in the style of Shakespeare. What you care about are two fundamental things. First, that it follows your instructions precisely, your business rules, your formatting requirements, your constraints, and your guardrails. Not just understanding them, but actually adhering to them consistently and reliably. And then second, that it's well grounded in the knowledge that it retrieves and that you provide. The model should not hallucinate. It should reason over your data and not make things up from things that it's seen during its training. Together, these two requirements give us what we call a grounded language model, or GLM, a model that's specifically optimized for these two specific capabilities, which is a subset of what a foundational model cares about. So now let's look at these two charts. On the left, we have Google's Facts benchmark. This is a recent benchmark that has been created by Google to measure groundedness, how well models reason over provided information without making things up. Our best grounded language model scores 90.7 on this benchmark, topping the leaderboard and outperforming all foundational models, including the latest Gemini 2.5 Pro from Google. But the right chart tells an even more interesting story, in my opinion. What's happening here is on the x-axis, we are evolving the system prompt, which basically means adding increasingly more constraints and rules. See how Claude 3.5, which is the orange line, starts strong when you have relatively few constraints in the system prompt, but then drops pretty heavily as you keep adding more. By the time you have over 10 different rules, its performance has degraded significantly. And we have found that this problem is especially bad when you're dealing with long context. So like models are good at following instructions when the context is short, but as soon as you have like 32K tokens or more of information that you've retrieved, the instruction following ability degrades pretty significantly. Originally, we struggled with this too. That's the light blue line on the chart. But by recognizing this problem and specifically targeting it in our training recipe, our GLM maintains strong adherence even with many specific instructions in long context settings. The bottom line here is that our GLM is a language model built from the ground up to follow your complex business logic while staying grounded in your data, exactly what enterprise agents need. So how did we build a model with these specific capabilities? Let me walk through our three-part approach here. First, we rely on synthetic data very heavily. Our synthetic data pipeline is essentially where we do System 2 to System 1 distillation. Think of it this way: System 2 is slow, deliberate reasoning, like a human expert carefully working through a problem step by step, whereas System 1 is fast, intuitive responses. So typically when a model responds just based on an input, you can consider that a System 1 process. Our synthetic data pipeline, which is the System 2 here, uses multi-step LLM programs that capture how experts think through problems, encoding their inductive biases, their checking procedures, their domain knowledge, and distills this into training data. Through this process, we're modeling both the input distribution and the system behavior to create a training data set that will induce the right behaviors and capabilities in our language model. The second thing that we've done here is we built a specialized reward model for groundedness. This classifier can determine whether any claim in a response is actually supported by the provided evidence. We have a model that is close to state of the art on a benchmark called LLM AgriFact, which is a challenging benchmark for factual consistency. And this reward model essentially gives us a reliable signal for whether the model is hallucinating or staying grounded that we can incorporate in both our data generation procedure and our training methodology. And then third and finally, our progressive training recipe. From SFT to GPO to GRPO, we start with supervised fine-tuning on our synthetic data to instill the right behaviors, and then given this relatively strong initial policy, we do DPO and GRPO using our groundedness reward model and LMUNit signals to continuously improve both the instruction following and the groundedness of our model. Each of these stages builds on the previous one, progressively refining the model's capabilities and hammering out all hallucinations that we observe. The key insight is that every part of this process injects human expertise, from the workflow design to the reward signals to the evaluation criteria, in order to train a model that excels at groundedness and instruction following. Now let's talk about evaluation. When you prompt an LLM to ask it which response is better, you're basically relying on its implicit understanding of quality. But whose definition of better is it using? OpenAI's, the internet's, random human annotators? You have no visibility or control over this process. Yet most people are using LLM as a judge as their primary evaluation metric. LMUnit aims to flip this paradigm. Instead of opaque preference judgments, you define success through natural language unit tests. Just like software engineering moved from "it works on my machine" or "it looks good to me" to principled, comprehensive test suites, we're trying to do the same for AI. The key principle here is that evaluation should be decomposable. You should break complex quality into specific, measurable criteria. It should be interpretable. You know exactly why something scored well or poorly. And most importantly, it should be in your control. You define what matters, not some black box model. How does this work? You write natural language criteria like uses active voice or includes specific examples or must mention 1 dB, and LMUnit was trained on a unique combination of preference data, direct scoring, and natural language rationales. By having humans define the criteria and a specialized model do the scoring, you get both human interpretability and machine scalability. You're not asking an LLM to guess what you want, you're telling it exactly what to measure. Let's look at the empirical results of LMUnit. First of all, LMUnit achieves state-of-the-art performance across multiple benchmarks. We're number one on Flask for fine-grained evaluation, number one on Big Bench, and top 10 on Reward Bench. You can check out our paper on arXiv for more results and analysis. Most recently, Reward Bench 2 was released, a newer, more challenging benchmark. Without any additional training or modifications, we tested LMUnit and we see that we achieved state-of-the-art results at 79.7, outperforming foundational models as well as specialized reward models. And really, this demonstrates the power of decomposed evaluation. While other approaches rely on learning implicit preferences from massive datasets, LMUnit is able to successfully generalize by making evaluation criteria explicit, interpretable, and measurable. And most importantly, these scores aren't just for benchmarking. LMUnit serves as a really good reward signal for reinforcement learning. But I'll get to that in a few slides when we talk about specialization. So far, I've talked about some of our state-of-the-art components: retrieval, grounded generation, and evaluation. A typical approach would be to chain these together in static workflows, and that works well for many use cases. But right now, we're trying to push beyond that. The next frontier that we're exploring is dynamic agents that learn to orchestrate these components intelligently. Instead of a fixed pipeline, imagine agents that can reason about complex tasks, knowing when to search for more information, how to decompose problems into subtasks, which tools to apply in what order, and so on. Rather than prescribing these behaviors through rigid rules, we're using reinforcement learning to let agents discover optimal strategies. To do this, we create diverse and complex training environments that mirror real enterprise complexity. Then we define rewards that encourage good outcomes, and we let agents learn through experience. This is where most of our research effort is going in right now, and this is clear, and it's clear that this is where AI is heading. From static workflows to truly adaptive systems that can handle long horizon tasks in complex, realistic environments. Basically, the full complexity of knowledge work. And just to share some of our preliminary learnings and lessons from our research on training agents with RL. First of all, initial policy really matters. You need a strong foundation, a model that already understands how to use tools before RL can enhance performance. What's really important to remember is RL refines capabilities, not rather than creating them from scratch. Second, error correction happens fast. Models can learn to avoid bad behavior pretty quickly, but developing sophisticated behaviors and emergent capabilities takes a lot of time. Often in the first 10 to 20 steps, agents quickly learn to avoid obvious mistakes. But learning complex strategies like efficient information gathering, decomposing problems, or knowing when to give up requires patient training with good reward shaping. And then third, process supervision beats outcome rewards. Take a look at this 1DB plot. The bottom line here shows what happens when we only reward the final answer. The performance plateaus and even degrades as agents learn to game the system and take shortcuts like relying on parametric knowledge. In contrast, the upper two lines show what happens when we reward the process, finding information piece by piece, explaining its reasoning well, following systematic approaches. And it's only by rewarding the process that we really see the agent continuously improve its outcomes. Now let's switch gears a bit and talk about specialization, going back to the GLM. The table here shows results across different, particularly challenging customer domains. Look at the consistent pattern here. The OOB column here, the out-of-the-box column, that's our GLM off the shelf without any prompting. It's already pretty good at grounding on your context, but it doesn't know anything about your specific domain requirements or the context of your app. The prompted column here is at about 66 to 78%, represents what we get after some serious human effort. Basically, we had human engineers carefully craft the prompts, encoding domain guidelines, business logic, and constraints. We hill climbed on held out evals and tried everything we could, and this is basically the ceiling of where you can get to with prompting. Specialization, on the other hand, breaks through this ceiling and achieves about 70 to 88%. And what's really remarkable here, in my opinion, is it takes less than 5 minutes of a person's time, often like 2 or 3 minutes. Basically, you provide a few examples of good outputs, define some key constraints, specify the criteria through some LMUT tests, and that's it. From this tiny input, we generate synthetic training data that captures your expertise, and then we fine-tune the GLM to embody your standards. There's no data collection, there's no annotation, just a few minutes of expertise transformed into 10 to 20% better performance than the best possible prompting. And this is the power of really effective specialization, minimal human input that gets transformed into maximum model improvement. Using RL with LMUnit takes our specialization to the next level. Look at those bars on the left. The base GLM gets about 3.1, after specialization 3.49, and GRPO with LMUnit rewards 4.02. That's another 15% gain on top of specialization. The key here is that the LMUnit tests that you defined become reward signals, and rather than prescribing to the model exactly how it should behave, you are allowing it to learn through exploration. LMUnit plus RL is how we push beyond the standard fine-tuning to create models that truly excel at your specific needs. Some open source plans that I just want to share. We're actually planning on open sourcing a lot of our key research contributions within the next 2 months. We're planning to open source our state-of-the-art text-to-SQL pipeline, the complete system that achieved #1 on BERT, LMUnit with the full training code and the full eval code to reproduce our Reward Bench 2 state-of-the-art results. We're planning to open source our grounded language model that tops the facts benchmark, and our complete specialization recipe, including synthetic data generation and RL infrastructure with LMUnit rewards. Follow us on Twitter and LinkedIn for these release announcements. So that's our approach, building AI agents specialized for your enterprises, not generic models that aim to fit everything. We've shown you how each component, from state-of-the-art retrieval to grounded generation to interpretable evaluation, comes together, how specialization with just minutes of expertise beats the best possible prompting, and how dynamic agents can learn to orchestrate these tools for complex real-world tasks. I've talked about some of our research efforts and learnings, but a lot of this is already available in our platform today. If you scan this QR code, you can get started with $25 in credits on our platform. And come find us at our booth. I'll be there for about the next hour and happy to discuss how we can build AI that doesn't just understand your business, but embodies your standards and expertise. Thank you for your attention.